So this is the fourth video on this link selection, and we have the radial line that's going from basically from this point on the coupler through the center of rotation for the link, and we're just going to extend that. Again, the velocity at this point would be perpendicular to this line. The velocity of this point would be perpendicular to this line. So we'll extend these two lines. And now we have the center of the instantaneous center of rotation for the coupler, but you can see it's pretty far away. It's way back here. And what we'll do is draw a radial line from this point out to the end point right there, and then just draw a perpendicular line. And that will be the direction of velocity. And again, if we calculate, if we know the angular velocity of the crank, we can determine the, if we knew this velocity right here, we can determine the rotational speed at that instant, and then take this distance times the rotational speed. That will give us the magnitude of this velocity right here, and we know that it's heading perpendicular to that radial line drawn to the instantaneous center of rotation. Okay, so we'll go ahead and get out of that sketch, turn the visibility off on that one, and create another sketch plane. Okay, so on this one, we're going from this point on the coupler down to the where the link connects down there. And so on this one, we're actually going to go, we want to have something that's collinear with that one. Right, I'm just going to check that. See, there's that. Yep, that's collinear. And the other line is going to go from this pivot point up to that point right there. Okay, so this velocity, we're not really sure what it's doing. It could be going perpendicular to the left or perpendicular down to the right this way. The crank one is still, it's going to be perpendicular to this radial line. That one's going counterclockwise, so it's still going in this direction. But now you can see that where these lines intersect, that the instantaneous center is actually right there. Okay, so the instantaneous center is right there, and I want to draw a radial line from that instantaneous center to this point right there. So I'm going to draw from here and then draw to the intersection. So that little symbol right there means the intersection of those. And now so the question is, what direction is this velocity going in? Is it going down this way to the left, or is it going up to the right? Well, if we look at this instantaneous center, we know the velocity right here is going to the left, because this crank, the crank is moving counterclockwise. So there's the instantaneous center. There's the point where the crank is going this way. So we know that the rotation of the coupler, this L shape, is actually clockwise, right? So from this point right here, this clockwise means that that direction, right, is going to be like that, right, perpendicular and in this direction. So that end point right here on the coupler, there's the instantaneous center. It's rotating clockwise, so the velocity is perpendicular in that direction. So at that point, we've determined the velocities on that front point for all three positions. And so at this point, you'll want to take a screenshot, maybe paste it into a Word document. You can either label it by hand, and I'm going to have to pick up with one more video on this.